Okay, so in this case we will solve a Taylor polynomial function. First of all, we will try to solve the derivative of this function. So we'll start saying the main formulas when we have a fraction. To start, I would say that the derivative of a fraction is the derivative of the numerator multiplied by the denominator. So in this case it's 10x minus 7 multiplied by x minus 1 multiplied by 5x squared minus 7x divided into x squared, because as I stated, the main formula is so imagine we have a over b f of x, so the derivative is the derivative of a multiplied by b minus a multiplied by b derivative over b squared. So we follow with the next polynomial, that is the derivative is 2x multiplied by 3 minus 0 x squared over 9, and then plus in this case if the derivative is 3 multiplied by 2x, so 6x. So now we start simplifying everything, and we will have 10x squared minus 7x minus 5x plus 7x over x squared plus 6x over 9 plus 6x equal 5x squared over x squared plus 6x over 9 plus 6x 5 plus 6x over 9 plus 6x, and the final result will be 20 out of 3x plus 5, and there we will have our first derivative, and we have to solve till the fourth derivative, and then we will plot each derivative into the graph, and that's it. We have here our Taylor polynomial.
Okay, so this is our function and this is the first derivative. We are going to continue doing the second derivative. That the answer is 2/3 plus 6. This equals 2 plus 18 over 3. 20/3. This is our second derivative. To continue, we are going to do the third derivative. That will be 0. To continue, we are going to substitute 0 in our functions. So f of 0 will be 5 by 0 minus 7 by 0 over 0 plus 0 over 3 plus 3 by 0. The answer will be 0. In addition, we are going to substitute the 0 in the first derivative, and this will be 5 plus 6 by 0 over 9 plus 6/0, and the answer will be 5. Here we're going to substitute the 0 in the second derivative, and because there is no x, we can't substitute it, so the answer will be 20/3. At last, we're going to substitute the 0 in our third derivative, and because the answer is 0, we can't substitute the 0 in the x, so the answer will be 0.
Okay, so then to find the third degree Taylor polynomial, we would use the formula, which is f of a plus f dash of a over 1 factorial times x minus a to the power of 1 plus f to the power of n over n factorial times a times x minus a to the power of n. So we would substitute with the numbers we have found earlier, and it would be third degree, so p3 of x equals f of 0 plus f dash of 0 x minus 0 to the power of 1 over n factorial plus f dash dash of 0 over 2 factorial x minus 0 squared plus f dash 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 of 0, which is the third derivative, over 3 factorial times x minus 0 to the power of 3. So then we substitute with the numbers we have found, which would equal 0 plus 5 times x minus 0 to the power of 1 plus 40 over 3 times x minus 0 to the power of 2 plus 0 over 6 times x minus 0 to the power of 3, which equals 0 plus 5 times x plus 40 over 3 x squared plus x cubed, which equals 5x plus 40x squared over 3 plus x cubed. And now this is the third degree Taylor polynomial that we have found, and we can use it later on to look for any number.
So in the function 5x plus 40x squared over 3 plus x to the power of 3, we're going to substitute x by 1.2 to see the value that it gives us. So we do 5 times 1.2 plus 40 times 1.2 squared over 3 plus 1.2 to the power of 3, which if we put it in the calculator, it gives us 26.928. So as we can see, Taylor polynomials help us to estimate values.